So now we're going to talk about sex-linked traits. So these are traits controlled by genes on the sex chromosome. And a gene on an X chromosome is called X-linked. So the best way to go about this is just to do a problem. So here's our problem. Color blindness is an X-linked recessive disorder where X with the dominant B is normal vision and X with the recessive B is color blindness. So if a normal vision male mates with a carrier female, what is the chance that this couple will have a colorblind daughter and a colorblind son? So as we did before with the Punnett square, we started with the cross, to write out the cross, and then we wrote out our key, and then we ended up with the Punnett square where we are able to then see the genotypic and phenotypic ratios. So we're going to do the same thing. So here it says if a normal vision male mates with a carrier female, what is that chance? So for the male, a normal vision male, so a male would have an X chromosome and he would also have a Y chromosome. So if he is normal vision, that would mean he would have this dominant allele. So that is normal vision. And if he mates with the carrier female, so a carrier female is going to have two X chromosomes, and because she's a carrier female, then that would mean she is heterozygous. So she would have a dominant allele, and she would also have a recessive allele. So let's write out our key so we know exactly what we're talking about. So if we have a dominant allele, that would mean you have normal vision. And if you had a recessive allele, in this case if you had two copies of that or only one, we'll see how it affects sons, then this offspring would be colorblind. Okay. So let's get back to our question. It is asking, what is the chance that this couple will have a colorblind daughter and a colorblind son? Okay. So a colorblind daughter and a colorblind son. Okay. So let's do the cross. We're doing a Punnett square. Since there's only 4 alleles, then that would mean we would have 4 squares. Draw out our Punnett square. I'm going to have my female here on the left side, and her genotype is she's a carrier female. So this is her genotype. So she's going to have X. And then on the top, it's going to be a male, and his genotype is an X chromosome with a dominant B and then a Y. And then we just complete a square like we've done before. So we have an X with big B's, or dominant alleles. And then we have another X with the dominant allele, chromosome with a little allele, dominant B and a Y, and then we have a little B and a Y. Okay, so here's our offspring. And if we go back to our question, it's asking about a colorblind daughter. So if we're looking for a colorblind daughter, you'll see here that only 2 of these offsprings are going to be daughter. So out of 2. To be colorblind, she needs to have two recessive alleles for color blindness, and we don't have that. So actually, we would have 0 out of 2 the chance of having a colorblind daughter. So no daughters would be colorblind. So 0 out of 2 or 0% chance. The other question is asking for a colorblind son. So if we look at a colorblind son, out of this we have 2 sons. Out of the 2 sons, if one of them has this recessive allele here for color blindness, which we do, then you'll have 1 out of 2 or 50% chance that you'll have a colorblind son, or that the offspring here will be that one of the out of the sons, a 50% chance that they'll be colorblind. So that's how you would solve this problem.